Okay, good morning. So let us start the lesson. Uh, Today we want to talk about geometric progression. So we learned about arithmetic. We learned about sequences first, and then we realized that there are different types of sequences. Two of them you will study in high school. One of them is called arithmetic progression, which was the topic of the previous lessons. Today we want to continue the same topic, but we switch to geometric progression. Okay, and I want to test this idea of teaching in this way now today. Let us see how it works. Okay. Uh, okay. So the outline of lesson today is actually I define what I mean by geometric progression, and then of course, as usual, I present some examples for you about geometric progressions, and then I determine the general term of a geometric progression. That is what we did for arithmetic progression as well, yes? And then when I introduce this, and then I will give you exactly, again, some examples. Okay, can you guess what will be the next? Because it is, I want to answer the same questions that I answered for arithmetic progression. Okay, so I actually define geometric progression. I present some examples that determine the general formula for the arithmetic progression, then give some examples. There is something left we did in arithmetic progression. I want to also answer the same question for a geometric progression. What was that? Yes? The sum. So I will determine the formula for the sum of the first n terms, and of course I will give you some examples. But then I will start solving a little bit more interesting problems on the next lesson. Okay, so that is very brief what we are going to do. Okay, the first thing, as I told you, I want to define what is a geometric progression. So let us just review a little bit what was an arithmetic progression. It was a sequence of numbers so that each term is obtained from the previous term by adding a constant number. Yes, that was called the common difference. Here, a sequence in which each term is obtained from the previous term by multiplying it by a constant term is called the geometric progression. Yes. And this number that you multiply to get the next term is called the common ratio. Okay, so and then usually it is denoted by R. In your book it is denoted by K because of the Swedish word for the ratio, but in the English books they show it with R, and that is called the common ratio. Yes, is that clear? So by the way, let me just give you some examples. So this is a geometric progression. Yes, 1, the next term is 2, the next term is 4, the next term is 8, the next term is 16. So what is happening every time I am multiplying a term by 2 to get the next term? Yes, is that clear? So this is the common ratio 2. Okay, so what is the common ratio here? What is that? Yes?
Times -2.
Is multiplying it by -2 every time. So the common ratio is -2. And for example, for this case, what is the common ratio? Yes?
Times the root of 2.
Yeah, I'm just multiplying it every time by square root of 2. Is that clear? So I have these 2. As I have square root of 2 the first term, I multiply it by square root of 2, I will get 2. And then I will take these 2 multiplied again by square root of 2, I will get 2 square root of 2. And when I multiply this by square root of 2, square root of 2 times the square root of 2 is 2, and then another 2 here, it becomes 4, and then you can continue. So that is called a geometric progression, very simple. Yes? Is that clear? Okay, and then this is somehow the definition in your book. So when you say, I just call this a remark. So if you have this sequence, it is called a geometric progression. This IFF means if and only if. If this happens, it means that if I take any term, n plus first term in this case, and then divide it by the previous term, which becomes an, it becomes a constant number r for every natural number n. So it doesn't matter if I divide a2 by a1, I'm supposed to get r. If I divide a3 by a2, I'm supposed to get r, and so forth. Yeah, please interrupt me if you have any question. Is that clear? Okay. So this is the first theorem that we want to describe. So we want to prove that, or to understand that, because the real proof of this is using mathematical induction. We haven't studied that yet, but this is the formula that I want you to know. The formula will be in the formula sheet. The main point is how to use it. So if you have this sequence is a geometric progression with common ratio r, then if you are interested in finding the nth term of that sequence, what you are supposed to do, you take the first term and you multiply it by the common ratio to power 1 less. So if you are interested in the nth term, the power that you choose here is n minus 1. Yes, and that is, I think, understandable. So let us go back on the board. So if I give you a1, it is just a1. But if I ask you what is a2, how do you answer the question? A2 by definition is the previous term, which is a1, and you multiply it by the common ratio. Yes, that's the mean. And if I ask you what is a to the 3, a sub 3, you would tell me that I will take the previous term, which is a2, and then multiply it by the common ratio. But the second term itself is a1 times r, and then I have another r here. And if I remove the pair of brackets, then I will get a1, r times r is r squared. Now let me just do one more. So a4 is the previous term, which is a3 multiplied by the common ratio, but I just found a3 is this expression. So instead of a3, I put this, so it becomes a1 r squared, and then I have another r. Yes, so this becomes a1 r to the power of 3. So if you want, I can write this one as a1 r to the power of 0. I just want to find a pattern. This is the reason that I'm writing it like this. So now you see that if the index here is 1, so a1 is, by the way, common to all of them. So you see, so if I continue this way, and if I want to write a sub n, my guess would be that there will be an a1 involved, there would be r involved, but I want to find the power. So if the index is 1, the exponent is 0. If the index is 2, the exponent is 1. If the index is 3, the exponent is 2, 4, 3. So then if it is n, that should be n minus 1. Yes? So that is the formula equivalent to which formula from arithmetic progression? Of course, I don't expect you to remember them because they will be in the formula sheet, but if you have it in memory, it doesn't hurt. Do you remember what was the counterpart of this formula in arithmetic progression? Yes?
Was it an equals to a1
Yes?
times
Not times.
plus
Plus
n minus 1 times d?
d. So that is exactly whatever you could do with this formula in the context of arithmetic progression. In principle, you can do with this formula, but in the context of geometric progression. Yes, is that clear? Okay. So let us do one example. It's a very, very simple example, by the way. So in a geometric progression, the 6th term is 53, and the 8th term is 477. Determine the 10th term of the progression. I would recommend you, because the problems are so simple, let me just pause recording a little bit so that you can have time to think about it. They are very, very simple problems, okay? And when you have the answer, please just let me know. Yes, do you have the answer? What? 901. So let me go to the next slide. This is the answer. So if I haven't done it wrong, this should be the answer to this problem. Yeah. Because you should expect, by the way, yeah, let us see how it goes. The numbers might be a little bit strange, but let us see how it will work. Okay? Of course, you might need a calculator, so that would be also good if you can help me to calculate, because I have used the calculator probably at home to answer the question. Okay, could you solve the problem? Yeah, let us solve it. It's not hard at all, yes? Because I just want to use this formula. Might be my answer is wrong, hopefully. So here it is not correct. Hopefully it is correct. So A6 is 53. So that what does it mean? Instead of A6, I use that formula. So it becomes A1 and the common ratio to the power 1 less. It is 6, so I have to write 5. It is given to be 53. That is one equation. And then I have another piece of information provided for me. So A8 is equal to 477. So what does it mean? It means A1 multiplied by R to which power? To power 7 is equal to 477. And my question mark is equal to A1 R to the power of 9. So in order to answer the question mark, I need to know A sub 1, I need to know the common ratio, and then put them in this equation to get something, to get a number for A sub 10. So this means that I have to solve this system of equations. This is a system of equations. Why? Because I have two equations and two unknowns. But this is not as a standard as in the case of arithmetic progression. What is your suggestion for me to how to solve this system? Because I need to find a way to find A sub 1 and R from this equation. Yes, Robert?
So I would divide both sides with, or the first one with R to the power of 5.
Yes.
Both sides, and R to the power of 7. I'll put both sides in there you get A1, and you can.
Yeah, that is the general strategy to solve all kinds of systems. You have to eliminate. So, for example, what Robert is probably saying is that you can find one of these variables in terms of the other one and use them there, yes? But in this case, I myself prefer to divide both sides. That's also possible for the specific form of this equation. So what I do, I will come back to you. So I will take A1 R to the 7, and I divide it by A1 R to the 5. And then on the right-hand side, this is 477, and this is 53. So is that understandable? So you are saying me that this number is 53, you are saying me that this number is 477. So when I divide this number by that number, it becomes 477 divided by 43. And then what happens? So this becomes R to the power of 2. Why? Because A1 and A1 are cancelled, and R to the 7 divided by R to the 5 becomes R to the 2. But on the right hand side, if you divide, what's the answer?
9.
9. Yes? But be careful, what is R then? There are two possibilities, both of them are acceptable. So R is not just 3, it is 3 or minus 3. So you need to consider both of them. Yes? So might be that is not the correct answer that I have provided. Might be there are two answers. Let us see. But now I need to know A1. Which one you prefer? I think this is easier, yes? I put this R back into this equation and I find my A1. So then from this equation I have A1 multiplied by plus or minus 3 to power 5 is equal to 53. But this number to power 5 is 243. If it is positive, when I raise it to power 5, it remains positive. When it is negative, when I raise it to an odd number 5, it becomes negative. So it becomes plus or minus. And then I will have A1, it's equal to 53. Yes? And then what I get also two answers for A1. So A1 becomes plus or minus 53 divided by 243. So that is my A1. Be careful, it means that if you choose the positive sign for R, you will get the positive sign for A1. And if I choose negative sign for a, r, I will get a negative value for a. Yes? But the answer, let us see, because what I have provided is just one single answer. Yes? So the answer was what? So the answer should be this one. Let us check. Okay, so I put this back into that formula. So the question mark is now equal to, instead of a1, be careful, I have two scenarios, plus or minus 53 divided by 243, and then I multiply it by r, which is again plus or minus 3, yes, to the power of 9. Yes? Okay, so I wasn't wrong actually. Do you think I will get two signs, positive or negative? I always get positive or I always get negative? What do you think? Because I have two scenarios, positive or negative, but this is odd, and this means that if it is positive, it remains positive because this is odd, and if it is negative, it remains negative. So this means that if I choose the positive sign here, I have to choose the positive sign here, and then when I multiply positive, positive, I will get a positive number. But if I choose a negative sign here, I have to choose the negative sign here, but when I raise it to power odd, it becomes negative, but again, negative times negative, it becomes positive. So for this particular term, I have only one option. In both cases, it becomes positive. 53 divided by that number is a very, let us see. Yeah, might be not that strange. So that is this number, and then 3 to the power of 9. Okay, do you remember what was this? This was 3 to power 5. Yes? When I was calculating, I raised 3 to power 5, I get that number. So this is clearly 3 to power 5. Make it a little bit simpler. 3 to power 9 divided by 3 to power 5 is 3 to power 4. And 3 to power 4 is 81. Now it is reasonable, I think. Yes, yes. If you multiply these two numbers, you will get 4293. Yes? So is that clear? Yes? No. Be careful. This is a good question, by the way. What he's saying is that here we have two options. Here we also have two options. So we can take positive with positive, one case, positive with negative 2, negative with positive 3, negative with negative 4. But this is not the case. Because if I choose positive, I will get only the positive value for A1. Yes, because if I take this one and take the positive value and put it back into this equation, yes, there is only plus sign. I will not get two answers for A1. I will get only the positive one. So if you choose positive, you are forced to get the positive one. And if you choose negative, you are forced to get the negative one. So this means that there are two scenarios going, not four. But that was a good question. Is that understandable? Okay, so now let us go to the next example. Okay, I want to wait for you to solve it for me because the questions are actually simple. So determine m so that m minus 1, 2m plus 6, and 4m plus 44 are consecutive terms of a geometric progression. We don't know which terms they are, but we know one is coming after the other. Consecutive means one coming after the other. So we want to fine-tune this m so that this becomes 3 consecutive terms of a geometric progression. And whenever you have your answers, you can let me know, please. Yes? Let me check. Yes, the answer is 5. But please continue. If you haven't done it, but you know that now the answer is supposed to be 5. Okay, what happened? Yes, let us solve the problem. At least you can tell me what to do with, yes? How to do it. What should I do? These three should be consecutive terms of a geometric progression. What is the starting point? What should I write? Yes?
Well, I would first say that A1 is equals to m minus 1.
Yes?
And that A2 is equals to 2
Yes.
minus 6 in the same.
Yeah. And then okay, this is good, but I prefer to do it a little bit differently. That's exactly what you are saying, but I want to do it a little bit more faster. So do you agree that if I divide this by that, it becomes equal if I divide this by that? Because they are supposed to be consecutive terms. If I divide this is not the second term, I don't know from which part of the progression I have taken it out. But I know that they are consecutive, so if I divide this by the previous one, it becomes the common ratio. This I know. And if I divide this by that, it also becomes the common ratio. So I hope that you understand that a good starting point is to put an equal, because you want to find an unknown. To find an unknown, you need one equality. So you need to set up an equality to be able to solve it, yes? So I would prefer to do it in that way. I think this might be faster. First of all, tell me that you understand the logic, yes?
Yes.
Is that understandable? So this question can be translated into this equation. And if I can solve and find m, then I am done. Do you agree? Okay. You can immediately start because you know that if a over b is equal to c over d, this is equivalent to saying that a times d is equal to what? B times c. So I can say that this multiplied by that is equal to this multiplied by that. I can immediately start doing it. But because I always care about simplification, I don't want to use the calculator as much as possible. So let me just try to simplify it a little bit before doing the calculation. So here I can factor a 2 out. This becomes m minus 1. In the denominator here, I also can factor a 2 out, which is essentially the same thing. And in the numerator, I can factor a 4 out. This is just for solving the problem simpler. And then these 2 in the denominator and that 4 are simplified too. And I have a factor of 2 here and a factor of 2 there. I can divide everything by 2. So this means that this factor of 2 will eventually cancel that factor of 2 as well. Yes?
Is it not possible to cross cancel the top left and the bottom right?
No.
Okay.
No, if that is happening, if you have the product and they are on the same side. Yes? So you can simplify this by that, yes? Or this by this by that. Okay, so this is the way. So what is left for me? Let me just write m plus 3 and then divided by m minus 1. On the right hand side, I will have just m plus 11, yes? And I have m plus 3. I hope that you agree that this, of course, this is the same equation, but with simpler numbers. So it is easier for me to solve it. Okay, and then I use this rule. I could use this rule before, but then I have to deal with bigger numbers. So then this means that this multiplied by that, but they are the same. So this becomes n plus 3 to power 2. And then I have m plus 11 multiplied by m minus 1. And this is just a very simple normal equation now. So I raise it to power 2. So it becomes m squared plus 6m plus 9. On the right hand side, I just multiply. So this becomes m squared minus m plus 11m minus 11. And then m squared, I move it to the left, we'll cancel this m squared. Minus m plus 11m is 10m. I move it to the left, it becomes 6m minus 10m. And I have minus 11 there. I move 9 to the other side, it becomes minus 9. And then this becomes minus 4m is equal to minus 20. And as Hadi mentioned, m is equal to 5. Okay, so that's the answer. which is of course confirms this. And that this is, do you remember I said something about consecutive terms in an arithmetic progression? Do you remember I told you that if A, B, and C are consecutive terms of an arithmetic progression, do you remember what was the nice relation between these three numbers if they are arithmetic progression? Yes? Middle value, average. So B is equal to A plus C over 2. This is for arithmetic progression. Now, if I change my point of view, can you discover something similar to this, but for geometric progression? Still, I'm telling you that A, B, and C are consecutive. Be careful, I haven't written it down on the board, but A, B, and C are consecutive terms in an arithmetic progression. That was the relation between these three numbers. Now I am telling that what can you say if A, B, and C are consecutive terms of a geometric progression? What can I write? Yeah, I got exactly the same thing, yes? B divided by A is equal to what? Is equal to what? C divided by B. And then this means B times B is B squared, A times C is AC. Okay? So here, if you want, I can change this a little bit. I multiply everything by 2. Then this becomes 2 of the middle one. 2 times the middle one is this one plus that one. But here what is happening, instead of 2 times B, I will have B squared. And instead of A plus C, I will have A times C. And by the way, this B is called arithmetic mean of A and C. That this B is called the geometric mean between A and C. These are just the words, you don't need to know them. These are not in the book. But this is a good relation to know. If A, B, and C are consecutive terms of an arithmetic progression, 2 times the middle one is the sum of these two. If A, B, and C are consecutive terms of a geometric progression, the middle one squared is the product of these two. Yes? That's also good to know. Okay. Now this is the third example. I want to pause the video from recording and I want to wait for you again. So let me just read it for you. So in a decreasing geometric progression, what do I mean decreasing geometric progression? Because for example, if I have a geometric progression, the terms can increase. But for example, if I take the common ratio to be 1/2, every time I'm multiplying by 1/2, the terms are decreasing. So what is the meaning of decreasing geometric progression? Hopefully it's clear. The sum of the first and fourth term is 56, and the sum of the second and third terms is 24. Determine the progression. I want you to solve it systematically, even if the numbers are so small that you can guess. Okay, guessing is not acceptable. By determining the progression, what I mean? If you want, yes?
Find the general formula.
No. General formula is good, but you don't need to find the general formula. For determine, yeah?
Find A1 and R.
R, yeah. Of course, if you have A1 and R, what you said is also correct. But determine the progression, it means that write it down, to be honest. But yeah, let us see. That it's understandable. So I want you to start working on it. Even if you can guess the numbers, this is not acceptable. You should be able to solve it systematically, okay? And if you have the answer, please let me know. Yeah, you might need this formula. This is always in the formula sheet on top, but might be you haven't have any problems using them. So I just write this here. I'm not sure, but I think you need this identity so that if you have a to the power of 3 plus b to power 3, this is a formula that you can immediately prove it yourself. And this is always in the formula sheet without probably you are using it at all. Okay, so this is the formula. So if I have the sum of two cubes, I can factorize it using this formula. And the proof of it is very simple. You just start multiplying things. A times a squared becomes a cubed, and you start multiplying. You see that all the terms will be cancelled except a to the 3 plus b to the 3. So you might need this formula as well. Okay, I will give you again time to think. Okay, no answers? Because I have to continue teaching, let me start see why the problem, where is the problem. So what do you think? If you want to start, what do you think? First of all, you don't, right now you don't need to think about this. But what is the starting point? Instead of, so if I want to solve this, I just write A1. But instead of A4, what can I write? I can write A1 multiplied by the common ratio, 1 unit less. Yes, this is the formula. And that is 56. Okay. This is the equation that I get from here. What I get from here, instead of a sub 2, I can write a1 multiplied by the common ratio r to the power of 1 unit less plus a1 r to the power of 2 is equal to 24. Again, you are facing a system of two equations and two unknowns, a1 and r. But the point is how to solve the problem. I think now you need that. Do you have any suggestions for me now? At least the starting point shouldn't be hard. What do you think I will do from on this side? Any yes? Pull out a, yes, we could just do the normal ones to see how it goes. 1 plus r cubed is equal to 56. What will I do here? I will pull 1a1 and r out, yes? So this becomes a1 r 1 plus r to the power of, just 1 plus r is equal to 24. The next step, can you tell me what to do for the next step? What? Because the goal is to get rid of one of the variables at a time. You have some experience in, I raised the problem, the first problem. Did you remember what I did to solve such a system? Yes?
You divide them.
Divide. So I will do the division again. Yes, because I will get rid of a1. So which one I will take? I will take this one, a1, multiplied by 1 plus r cubed, and I divide it by a1 r times 1 plus r. On the right hand side, I will have 56 over 24. First of all, tell me, is that understandable? Yes, I divided this by that, so this means this becomes equal to 56 divided by 24. Some simplifications I can do. So this a1, whatever it is cancelled, so that's good. What is left for me is only one unknown, that is r. Of course, the problem is a little bit harder than the previous one, but at least it is a good progress because I have only one variable left. So this becomes 1 plus r cubed divided by r, 1 plus r. On the right hand side, I can divide by what? To simplify 56.
8.
And by 8, it becomes 7, and it becomes 3. Okay. If I just immediately want to use this, then what will happen? I will face a third degree equation. And if you are familiar, I told you that if up to second degree, it is easy for us to solve. But when it goes higher, then it becomes a little bit problematic. But then this is the reason that I gave you that hint. So can you see how can I use that formula in this equation now? Yes?
1 plus r to the power of 3.
Can be factorized because 1 is also a complete cube, yes? So if I give the role of 1 to a, and if I give the role of b to r in this, then what will happen? In this equation, I will have 1 to power 3 plus r to power 3 is equal to 1 plus r, 1 to power 2 minus 1 times r plus r2. So that is the formula. I replaced a with 1, I replace b with r, then I get this. Yes? But then it is easy to see that 1 to power 3 is just 1, r to power 3 is r3, and then I have 1 plus r, 1 to power 2 is 1, minus 1 times r is minus r squared is r squared. Yes? Okay, so this means that hopefully now you understand what is going on. So this was needed probably, but this is, by the way, the formula sheet. So I go back here and I want to use that formula. So let me just make everything in front of you. Okay, so instead of 1 plus r3 in the numerator here, I just write 1 plus r times 1 minus r plus r squared, and I divide it by r times 1 plus r is equal to 7 over 3. Yes? And then you see that this, whatever it is, will be cancelled with that one. So the degree left is 2 rather than 3. And then in principle, I should be able to solve it. So this means that I get 1 minus r plus r squared divided by r is equal to 7 over 3. And then I have to solve this. This is simple. So what I do, I multiply 3 here, and then I multiply 7 there. I multiply in. So 3 minus 3r plus 3r squared is equal to 7r. So I would write 3r squared first. I move 7r to the left. It becomes minus 10r. And then I am left with this constant term 3. Yes? And then I solve it. I use ABC formula. So r becomes minus b plus or minus the square root of this number to power 2 minus this 4 times this times that, which is minus 36, and then divided by 2 times of this number, which is 6. 100 minus 36 is 64. Square root of 64 is just 8. Yes? And then I get 2 answers. So r is 10 plus 8, 18 divided by 6 is 3. Another one, 10 minus 8 is 2. 2 divided by 6 is 1/3. Okay, which one is acceptable? Yes? Yes? 1/3, yes, because of this word decreasing. Yes, so this is telling you that this geometric progression is supposed to be a decreasing one. So I'm not allowed to choose 3, because if I choose 3, every term will be bigger and bigger. Yes, so I have to choose the other one. Okay, so this is acceptable. Okay, when r is 1/3, what should I do? I need to find r as well. So what is r? So that is r. I need to find a1. So I would prefer to put it in one of these formulas. Probably it doesn't matter. For example, let us put it here. I can clean this one now, yes? So if I go back here, a1 plus 1 over 3 to power 3 is 1 over 27 is equal to 56. And I take the common denominator. So this becomes a1. It becomes 28 over 27. If you take the common denominator here, it's equal to 56. And then again, 28, I can divide, this becomes 2 times. So then a1 is 2 times 27, which is 54. So it is determined, yes? So if I want to write the answer, for example, the first term is 54. The next term is this number multiplied by 1/3. The next number is 6. The next number is 2. And then you can continue this list. Yes? So that is the one you get. So that is written here. So, but this was a little bit harder problem because you need to remember, I don't know, you need to be able to use this formula as well. Any questions? Okay. So now we want to find a formula. That is the last part of our lesson today. We want to find a formula for Sn in a geometric progression. Okay? We want to prove that if this is a geometric progression with common ratio r, but there is one exception that this formula will not work, and that is the case that r is equal to 1. And I will tell you, r equals to 1 is not an obstacle for us. So if this is a geometric progression with common ratio r, which is not equal to 1, then Sn, the sum of the first n terms of this geometric progression, is this, following this formula. Some books write this like this, some books write it like this. I want you to understand that these two formulas are the same. Yes? So it doesn't matter. I think in your book it is written in this form, but you might see in some books they have written it in this form. Can you immediately realize that these two are exactly the same?
Yes.
Why is that?
One is the negative of the other.
No, if one is the negative of the other, they are not equal. But you are right, yeah?
I mean, it's because you have a switch, so first is 1
Yeah,
minus.
both the numerator and the denominator are the negative of the corresponding ones, yes? So it means that I have rescaled the fraction by a -1. If you multiply the numerator of this by -1, you get this, but of course, you have to multiply the denominator of this one by -1 as well, you will get this. So it doesn't matter. Hopefully you see that these two formulas are the same, but I myself prefer to use the one is written in the book, which is this one. And then I have written this in red. Remember, Sn means the sum from the first term up to and containing the nth term. Okay, not just any n terms. It should be in order. So the first thing comes after a theorem. You expect to have a proof, so I will prove this on the board, okay? But can you tell me, can you tell me what is the strategy? Think about the strategy of how to prove this. Yes? So we had some strategy. I don't know how many of you remember. Do you remember what was the strategy for finding Sn in arithmetic progression? That example that I mentioned from Carl Friedrich Gauss, yes, he was able to solve that problem when he was in the first primary school. First, yeah.
Telescopic sum?
No, it was not telescopic sum. It was the idea to write the sum the other way around. Yes, for example, if you are supposed to add 1 up to 99, you write it from 99 to 1 and then add them up. You get 2 times that sum, and then at the end you divide by 2. Okay, can you think what can I, because this probably will, this idea, first of all, see if this idea will work for this case. If not, can you understand what we can do to find this formula? Okay? Okay, any ideas? So let me write down here for you. So for example, assume that you have A1, A2, A3, up to A sub n. This is a geometric progression. Yes? And my goal is to find a formula for Sn. What is Sn? By definition, it is A1 plus A2 plus A3 up to An. And I know that the common ratio is not equal to 1, but it can be any other numbers. Okay, any idea of what I'm going to do? I want to find the formula for Sn, which is written in terms of A1, R, and N. So this is the formula. Let me just write it in front of you. So A1 times 1 minus R to power N divided by 1 minus R. My goal is to show that Sn is this expression. So you see that in Sn, what I need R, I need N, I need A1. So I want you to find the formula so that I can give, if I give you these 3 quantities, you can give me Sn. So what do you think is a good method here? Okay, I give you a hint, but you tell me why it works, okay? You multiply your sum by minus r, okay? So I will multiply it by minus r, everything. Now, can you see why this will work? Okay, tell me at least something. What can I write instead of this? This is very simple. R times A1, this is a geometric progression. So when I multiply A1 by R, what do I get? Yes, this becomes A2, I have a negative sign, it becomes minus A2. So this is nothing except minus A2. Okay, what happens for the next term? This is A2, I am multiplying it by R. So what do I get? I get A3, because of this negative sign, it becomes negative A3. Yes? And then what is this one? It's negative A4. Yes? And then, I continue here. Can you tell me what is the previous term that I haven't written it down? It is minus R, A sub n minus 1. Do you agree?
Yes.
So if I multiply this A sub n minus 1 by R, it gives me an. But I have a negative sign, so it becomes minus an. But then I have to write this down here. Yes, is that correct? So this becomes minus A2, minus A3, minus A4. This becomes minus an. Then the last one, I just copied and pasted that last term here. And now, what is the idea? Can you tell me what's the idea? I want to get rid of most of these terms, yes? So I will add this to that. So what happens? This gives me Sn minus Rsn is equal to. Look at this blue line here. I want to add the blue line to this black line here. But what will happen? This minus a squared, a sub 2 will cancel this one. This one will cancel that one. Minus a4 will cancel the next one. If you continue, the last term will cancel the last term here. So what is left? There is one term here surviving here, and there is one term here which is surviving. And then it means that I have to write A1 minus R, ARN. Yes? Is that clear? Okay, then on the left-hand side, what can I do? Sn, I can factor it out. From this one, 1 is left. From this one, R is left. And on the right-hand side, I can write A1 minus R. Instead of an, I use the formula. It is A1 R to the power of n minus 1. So then it becomes 1 minus R Sn is equal. Between these two, I can factor A1 out. From this one, 1 is left. But here I have R, which is supposed to be multiplied to R to power n minus 1, which gives me R to power n. Yes? And then I am looking for Sn. I want to make Sn isolated, so I divide everything by 1 minus R, and then you realize for this part, it is crucial that R is not equal to 1. Because if R is equal to 1, this is 0, and I am not allowed to divide by 0. So because it is mentioned that R is not equal to 1, then what can I say? I can say that, okay, Sn is equal to A1, 1 minus R to the n divided by 1 minus R. This is the formula for the sum of the first n terms in a geometric progression. This is comparable to this formula for arithmetic progression. Yes, whatever you could do with this formula in arithmetic progression, now you can do it with this formula in a geometric progression. Okay, there is one question that I want you to answer me. What happens if r is equal to 1? It means that we cannot solve the problem, or what? This formula, of course, will not be valid for r equals to 1. But do you think that r equals to 1 is a big problem for us? Why?
If r is equals to 1, that means that every term is the same.
Yes. So for example, if the first term is 5 and r is 1, the next term will also be 5, 5, 5. Yes, and if I ask you what is Sn, can you immediately answer that? What is the answer? 5 times n. So for the case that r equals to 1, we don't need any formula. Yes, we can solve it. But if r is not equal to 1, then these terms are different, then we need a formula, and that formula is this one. Is that clear? Okay. So now let us go to an example. So I want to wait for you because I think this is the last example of this lesson. Let me see. Yes, I'll expose the answer. No, we have 2 more examples. Okay. So anyway, we want to solve this in a geometric progression. The first term is equal to 6, and the common ratio is equal to 2. Determine the sum of the 5 first terms of the progression. The point of this exercise is just to memorize the formula or to use it. Okay? Yeah, I think I can do it myself because this is very simple. So, the first term is equal to 6. This is example 4. Yeah, we can do this. It is given the first term is equal to 6 and the common ratio is equal to 2. You are supposed to determine the sum of the first 5 terms. 5 terms, yes? Okay, so that's very simple. I just need to read the formula from the formula sheet and answer the question, yes? So this means that S number 5, S5 is equal to A1, which is 6, 1 minus R, which is 2, to the power of N, which is 5 in this case, divided by 1 minus 2. So I have just taken the formula and replaced the numbers with the given values. And then you calculate that. This is very simple. So this is 2 to the power 5, 32, 1 minus 32 minus 31. This is also minus 1, so it becomes 31. If you multiply that, it becomes 186. So that is very simple, actually. Do you have any questions here? Okay, so that was the answer, 186. But I want to give you a little bit of time to think about this. This is the last example for today, okay? So in a geometric progression, we know that A5 minus A1 is 20, and we know that S4 is 10. Determine the common ratio of this progression. So they are just asking you to find R. I pause recording and then I give you time, solve it, and then the lesson will be finished. Whenever you have your answer, please let me know. Yes? Is 3? R is 3? Let us check that. Yeah, that's correct. Okay, so let's just solve this problem and the lesson. So here, if I want to solve it, instead of A5, you know that you can write A1, R to power 1 unit less, minus A1 is equal to 20. And then let us, by experience we got so far, let us factor A1 out. R to the 4 minus 1 is equal to 20. So we cannot continue anymore. Let us see what happens from the other piece of information. So S4 is 10. but you have the formula of Sn on the board. So what I do, I replace n with 4. Then what will happen? It becomes a1, 1 minus r to the 4 divided by 1 minus r is equal to 10. So that's a system of equation. But actually it was much simpler than I thought, yes? Can you tell me what to do? It's more or less evident what to do. You can divide, but simpler than that. Division is correct. But you see, this expression is more or less the same thing as here. But only, so can you tell me if this number is 20, what is the numerator of this one? Yes?
Is it minus 20?
Minus 20, yes, because what I have done, if you multiply everything by a minus sign, this becomes minus 20, this becomes minus r to the 4, but this becomes positive 1. So if this is 20, this expression is minus 20. So then it means that this means minus 20 divided by 1 minus r is equal to 10, but 10 means 10 over 1. I can simplify 10 with 20, so it is minus 2 times. It is left 1, and then I would say 1 minus r times 1 is equal 1 times minus 2. Then if I move this to the other side, minus r becomes minus 3. And then as you mentioned exactly correctly, so this becomes 3. So r becomes 3. Yes? Of course, I will spend one more session on geometric progressions to solve a little bit more interesting problems, and then we go to the next and last part of this chapter, which is a very important topic of mathematical induction. Any questions? Yeah, the answer is 3. Any questions? Okay, thank you very much.